For decades, one name above all others meant one thing in the automotive world: reliability. Not just good reliability, not just above-average reliability. The kind of reliability that made mechanics nervous. The kind that made accountants sweat. The kind where a truck built in 1994 is still running in 2026 with the original engine. That name was Toyota. And for a long time, Toyota wore that reputation like a badge of honor. They built it deliberately, intentionally, almost obsessively. But here's the question nobody was asking in the boardrooms of the late 1990s. What happens when a company builds a product so good that it stops being profitable? What happens when your engineering is so far ahead of your business model that the two can no longer coexist? Today, we go inside both the engine bay and the boardroom to uncover the story of two engines, the two JZ and the one HZ, that were built to last forever, until Toyota decided that forever was too long. And by the end of this video, you'll understand why your 2026 Toyota feels fundamentally different from your father's 1994 Hilux. It's not just about emissions, it's not just about technology, it's about a decision. A calculated, deliberate decision. And once you see it, you cannot unsee it. To understand what was lost, you first have to understand what was built. Let's start with the two JZ GTE. 1991. Toyota needs a power plant for their flagship sports car, the Supra, Japan's answer to the Porsche 911, the car that was supposed to prove Toyota could play in the big leagues. So their engineers sat down and did something extraordinary. They built an engine not just for the power it needed to make, but for the power it might one day be asked to make. The block was cast iron, thick-walled, the kind of construction you'd expect in a truck engine, not a sports car. The internals were forged steel. The head bolts were over-spec'd. The oil squirters, small jets that spray oil directly onto the underside of the pistons to keep them cool under stress, were standard from the factory. From the factory, the two JZ made 276 horsepower. That was the official number, limited by what was then known as Japan's Gentleman's Agreement, an informal cap between Japanese manufacturers to keep factory power figures below 276 horsepower for insurance and road safety reasons. But here's what the engineers knew and what they never officially said. This engine was built for 800 horsepower. Not modified, not rebuilt. Stock. The same block you pulled off the showroom floor, with a larger turbo, upgraded injectors and a retune, 0 internal modifications, the two JZ would produce over 600 horsepower reliably. Push it further, and 800 was achievable on the factory internals. Why? Because Toyota engineers built to a safety factor of 2. Most manufacturers target 1.2. Toyota doubled it. They built an engine that could handle twice its rated output, by design. Now shift your attention to the other side of the garage, the 1HZ diesel. Where the 2JZ was the performance legend, the 1HZ was the workhorse god. No turbo, no electronics, no variable valve timing, no sensors that could fail in the Sahara or the Australian outback or the mountain roads of Afghanistan. Just pure mechanical compression ignition. Air goes in, fuel goes in, heat does the rest. The 1HZ powered the 70 series Land Cruiser, the vehicle of choice for the UN, the military, aid organizations, and anyone who needed to get somewhere remote and come back alive. And it ran, and ran, and ran. Stories of 1 Hertz engines crossing 500,000 kilometers without a rebuild are not myths. They are documented. They are common. Both engines shared one philosophy: push the failure point so far beyond the vehicle's expected lifespan that it becomes effectively irrelevant. In engineering, this is called over-engineering. In business, it has a different name: a problem. By the late 1990s, something was changing at Toyota, and it had nothing to do with engineering. The global economy was shifting. Toyota had gone from being a manufacturing company that happened to have shareholders to a financial entity that happened to manufacture cars. And in that world, a 30-year engine is not an asset. It is a liability. Think about it from the boardroom's perspective. Toyota had over 1,500 dealerships globally, each one dependent on a revenue model built around two things: new car sales and service income. New car sales depend on people replacing their old cars. Service income depends on things going wrong. An engine that runs for 30 years does neither. The customer who bought a 1994 Land Cruiser with a 1HZ engine is still driving it in 2010, still driving it in 2015, still driving it today in some cases. They are not buying a new vehicle. They are not generating service revenue beyond oil changes and tires. They are, from a financial modeling perspective, dead weight. So the question that started appearing in Toyota's internal strategy documents, though they would never phrase it this way publicly, was simple. How do we transition from a company that manufactures the best product to a company that manufactures the most profitable product? The answer was already being implemented by every other major manufacturer. Planned replacement cycles, designed-in service intervals, electronics complex enough to require dealer tools, components with finite thermal lives, plastic intake manifolds, aluminium blocks, rubber-lined timing chains, not designed to fail, but designed to not last forever. There is a subtle but important difference. Toyota had spent 40 years becoming the global standard for reliability. They could not simply flip a switch and start building disposable cars. The brand damage would be catastrophic. So instead, they did something far more elegant. They killed the engines that proved the old philosophy, quietly, with justifiable reasons, and replaced them with something that, on paper, was better. Ask any Toyota representative why the 2JZ was discontinued, and they will give you the same answer: emissions. And they are not lying. Euro 3 gave way to Euro 4, then Euro 5. The EPA in the United States tightened its standards. The old mechanical fuel systems and cast iron architecture of the 2JZ could not meet modern requirements without an overhaul that would fundamentally change what the engine was. The 1HZ faced the same fate from the diesel side. Common rail injection, particulate filters, EGR systems. The regulatory environment made the simple mechanical diesel increasingly difficult to certify. So yes, emissions killed these engines. That part is true. But here is what they don't put in the press release. The replacement architecture that Toyota moved to, aluminium blocks, plastic composite intake manifolds, variable valve timing systems with timing chain tensioners on precise maintenance schedules, was not just cleaner. It was also cheaper to manufacture, lighter, which improved fuel economy numbers, and critically, it had a finite thermal cycle life. Aluminium expands and contracts at a different rate than steel. Every heat cycle, every time the engine warms up and cools down, stresses the metal slightly differently than a cast iron block would. Over 200,000 or 300,000 kilometers, this matters. Plastic intake manifolds are lighter and cheaper than aluminium. They also degrade. They become brittle with repeated heat exposure. They crack. Eventually, they need replacing. None of this is accidental. Now let's talk about the most visible symbol of this transition. In 2019, Toyota brought back the Supra, the car that made the 2JZ famous. The car that a generation of enthusiasts grew up idolizing. They did not put a Toyota engine in it. They put a BMW B58 inline 6 under the hood. Think about that for a moment. The company that built the most famous sports car engine in tuning history, an engine so overbuilt that it became a cultural icon, decided that building an equivalent in-house was not worth the investment. They outsourced their own legend. Because building a 2JZ successor would have required an enormous development budget to produce an engine with the same overbuilt characteristics, an engine that tuners and enthusiasts would run for 30 years without buying another car. The numbers did not work. The BMW B58 is an excellent engine, genuinely excellent, but it is a modern engine, built to modern business logic, and that tells you everything. This is not a story unique to Toyota, but Toyota is the most painful example because the contrast is the sharpest. The modern Toyota engine lineup is technically impressive. Variable valve timing on both intake and exhaust, direct injection, turbocharged 4 cylinders producing power figures that would have required a V8 30 years ago. The D4D common rail diesel systems in Land Cruisers are genuinely sophisticated pieces of engineering. But here is what changed. In the old world, a single sensor failure was an inconvenience. You removed it, cleaned it, possibly replaced it for $20. The engine kept running without it. In the new world, a camshaft position sensor failure, a VVT solenoid fault, an EGR valve sticking open, these can put a vehicle into limp mode or prevent it starting entirely. The ECU interprets an abnormal reading and shuts the system down to prevent damage. This is not bad engineering. In many cases, it is genuinely protective. But it means that a vehicle which would have limped home in 1994 now needs a flatbed truck and a dealer diagnostic scan. And that is not a coincidence. Combine this with the leasing revolution. In the 1990s, most people bought cars and kept them. A 10 to 15-year ownership cycle was normal. Under that model, reliability was the ultimate selling point because you were going to live with this machine for a decade. Today, the average new car lease runs 3 years, possibly 5. If your customer is handing the car back in 3 years, why build it for 30? Why engineer a block to handle twice its rated power output when the car will be traded before anyone pushes it anywhere near its limits? The economics of over-engineering evaporated, and the 2JZ philosophy evaporated with them. The market does not lie. A clean MK4 Supra with a 2JZ engine sold for under $20,000 in 2005. Today they trade for $80, $90, sometimes over $100,000. A 70 series Land Cruiser with a 1HZ diesel in good condition, $40, $50, $60,000 for a truck platform that was first introduced in 1984. These are not collector cars in the traditional sense. They are not rare. Millions were made. They are valuable because people trust them, because the people who own them know what is under the hood, and they know that it will still be running when everything else has been scrapped. That is the market's response to the death of reliability, and Toyota sees it. They are not blind. The Gazoo Racing division, the GR brand, is Toyota's attempt to recapture something of that old spirit. The GR86, the GR Yaris, the GR Corolla. These are genuinely enthusiast-focused machines, built with real attention to driver experience. But they are not 2JZ engines. They are not 1HZ engines. They are modern engines with modern lifespans, built under modern financial logic. So here is the final verdict. Toyota did not lose the ability to build a million-mile engine. They still have engineers who could do it. They still have the metallurgical knowledge, the casting techniques, the tolerance specifications. They simply chose not to. Because in a world of 3-year leases, subscription services, and quarterly earnings calls, the 2JZ was not just an engine. It was a threat to the business model. An engine that ran forever was an engine that never needed replacing. And in the modern automotive economy, that is not a feature. That is a problem. The 2JZ died not because it failed. It died because it succeeded too well. And somewhere in a workshop right now, in Japan, in Australia, in Pakistan, in Texas, there is a 30-year-old Supra with a 2JZ under the hood, and it is running perfectly. That engine does not know it was supposed to be retired. Nobody told it to stop. But there is one brand that still holds the secret to building engines this way. One manufacturer that never fully surrendered the old philosophy. That video is next.